Hello everyone. In this video we are going to discuss about integration. So basically the introduction of integration. Why we need integration? Integration we need to find areas, volumes and many other useful things. So how to find out the area with using integration under the curve of a function? That's the first thing we are going to learn here. This is your x-axis, y-axis, and suppose one curve I have in this format. So using integration we can find out the area of this curve. How we can do it? So let's just see it. So we will imagine couple of slices like this. Each slices will have equal width. So each slices will have equal width del x. So now if I'll add the area of these slices, we'll get the area of the curve. But if you can see it, there are some portions which are not covered, these portions, right? So the thing, we are going to not get the correct accurate area. So further, if we just change the width of the slices and make it more thinner, what will happen? I make it more thinner. So do you agree that this time the answer will be far better? Do you agree? So this del x, this is the width of these slices. If this del x is getting thinner means it is going to 0, tends to 0. This del x tends to 0. So that time we are getting the correct, not correct, accurate answer, you can say, right? So as these slices are approaching towards 0, we can write dx, which means the slices are approaching towards 0. So what is integration? Integration is adding up of the area of those slices, adding up the area of this slice. How to represent integration? We write like this. This is the stylus S, which denotes the sum, idea of summing of slices. So then suppose we are supposed to integrate 2x dx. If I integrate that, I will get x square plus c. So from where we are getting this c? That's the next concept. Now integration also we know, maybe already you have known this term, integration as the opposite of differentiation, as the reverse order of differentiation. Like many times you heard this term that ddx of sin x is equals to cos x. So later on you will get integration of cos x dx as sin x plus c. So from where this c is coming? Let's discuss that thing first. So as I am discussing integration, I can assume that all knows about differentiation. So ddx of x square, if I will ask what is ddx of x square, all of you can answer, I guess it is 2x. If I will ask ddx of x square minus 3, what will be the answer? 2x, right? ddx of x square plus 5, 2x, because we know that ddx of 3, ddx of 5, ddx of any constant is equals to 0. Integration is the reverse operation of differentiation. Now if I will integrate 2x dx, for this function I will get x square. Integrate 2x dx, x square minus 3. Integrate 2x dx, x square plus 5. Three different answers are coming for integration of 2x dx. Right? So just to avoid this confusion, what we do, because we know that when we will differentiate any constant, I will get 0. So just to assume that if I will integrate there might be some constant. Always when I will integrate any function fx dx, better if you write f dash x, we know dx of fx is f dash x. So integration of f dash x dx, I will write it as fx plus c. This constant is known as integration constant. Thank you. I hope all of you understood this.